What is knowledge? What do we know about the world? How do we name our knowledge using language? How do we use computers to store, represent and spread the knowledge among us? These kind of questions are essential in modern society, but they also relate to age-old philosophical questions. They relate to linguistics, cognitive science, psychology, etc., etc. Multiple disciplines tackle the same questions related to knowledge, meaning. How do we understand the world around us? We can have or see multiple paradigms or approaches to representing or understanding knowledge. One division is to think about theory-driven approach, where we construct a view on our world in our thought, so that then we use this as a basis of the representation of knowledge. We can also take a data-driven approach, which has become popular in recent years. We can see another division. We can divide the approaches to symbolic approaches, representations based on the idea that the world consists of items, objects, entities, and the relationships between these entities. And then we have another approach where we think that we represent the world as patterns, often in methodological terms and in vectorial form. So if we think about the world around us, so do we see around us trees, paths, sky, whatever, or do we see patterns of complex sensory items or sensory inputs to our systems consisting of thousands, millions of details that we then have to process in order to understand them? These are the kind of basic questions that need to be dealt with when we are thinking about how to represent, process knowledge, and how to do it also with computers. Is the knowledge of the world, is it an individual matter, or does it concern a large number of people? At least we can say that the language is a social phenomenon, a social construction. We share language. On the other hand, there are subjective aspects of language use. Also, when we consider the knowledge of the world, we specialize. We have different aspects of the world. One can ask, to which degree knowledge is an individual matter? To which degree is it a social, a shared matter? We learn individually. We can even construct knowledge individually by research that we conduct, by experience in the world, by building new theories and ideas. But on the other hand, of course, knowledge is also to a large degree a shared phenomenon. Language we use is shared with smaller or larger group of people, and even otherwise we share knowledge. An important division is between explicit and implicit knowledge. Explicit knowledge is often considered to be expressed in linguistic form, in words, in sentences. On the other hand, we have implicit knowledge of the world, which could be considered to consist of our intuitive understanding, individual intuitive understanding of the world, which we often do not and cannot express in detail in linguistic form, in symbolic form. In other words, intuitive knowledge can be understood as a kind of pattern-like understanding of the world and understanding of the relations and complex relations between things in a way, in a probabilistic or statistical way. Considering intuitive understanding, it has been for a long time even a mystery, but during the recent years it has become more understood or more clearly understood what intuitive knowledge and understanding of the world could be. And at least one methodological approach is to address this phenomenon using so-called artificial neural networks, or in general the approach is called statistical machine learning. Both in philosophy and computer science, it has been commonplace in many paradigms and theories to start from the assumption that the world consists of objects, maybe their properties and relations between the objects. This is understandable. First of all, our language is symbol-like. Different words, especially in written form, it seems that the world is really divided into different items. Moreover, especially our constructions made by humans, trains, chairs, houses, whatever, even ourselves, we see things as separate and individual items. And then we can consider classes of these items, classes of these objects. The class of chairs, the class of tables, categories. But anyway, the idea is that the world consists of a number of separate objects. On the other hand, even if we take a leaf, but if we think about the pattern that we see of the world, so if we see the nature around us, where do the leaves start and where do they end? Where do the mountains start? Where do they end? Where does a street around us, where does it start and where does it end, strictly speaking? How do we make a division between different aspects of the world? So it seems to be clear that some patterns of reality are easier to divide into separate objects and some are more difficult. The first ones are the ones for which this kind of linguistic symbolic approach is kind of easier, and the theories are naturally so. And for example, early Wittgenstein in his Tractatus took this approach into a very fine conclusion, but also at the same time seemingly with serious limitations that he overlooked. And nowadays we have alternative approaches that we can take to understand these questions. The idea of items, entities, objects of the world and their symbolic representation as a form of storing knowledge, understanding knowledge, kind of neglects one or two important aspects of knowledge. For us individual humans, knowledge of the world is contextual. We generalize, but at the same time what we experience takes place in context, and we understand matters of reality in the context. And the context tends to be always, at least to some degree, different from any previous context that we have experienced. Moreover, knowledge of the world is not only static, but it's processual. We are in the world, and the world moves around us in various ways. And that means that this kind of representations that are based on static aspects or focus on static aspects easily left out important aspects of knowledge. Books and other forms of written materials are, of course, very important forms of storing knowledge. And libraries are central institutions in modern information society and have been such for hundreds of years. Developments related to computers and computer networks have changed the role of libraries and the form of the materials. So often the materials are in digital forms, stored in computers, and can be distributed with the help of computers. Libraries are also an excellent place to consider one aspect of knowledge, that of categorization or classification. So, libraries typically organize their contents based on some categorization system which has been standardized, and the idea is that the knowledge, its description, can be standardized, and each item, in this case book or some other form of printed material, can be stored so that it's within some category. This, when we think it more carefully, of course poses some obvious problems. One item, such as a book, could, or most often we could claim, belongs to several categories. And maybe we can consider that they belong to some category to a degree. So the classification is not straightforward.
Can see me before the end of this week. Or the end of next week. So I will start sending out the presentation. So he said, okay. Then he said, hello, are you there? Hello. Okay. What about that girl? Your mom was telling me something. I'm like, yeah. So what about her? You've not told me anything. I told him. He said,
Helsinki Book Fair, with its popularity, is a good example of the importance of books and written and printed culture in modern society. Computers are being used widely in ever-growing areas of research and practice. Machine learning and artificial intelligence have been areas of research and development for more than 50 years, so they are not any new phenomena. But their significance and impact has been growing during the recent years, thanks to the increased capacity and maybe also to the better systems and better methodologies that are available. Computers are being used also for knowledge representation, meaning processing in various ways, which are significant, and they also relate to the questions which are philosophical in their nature. Both theory-driven and data-driven empirical approaches can be considered. Computers are programmed, and often this kind of even a misconception is that programs or computers do only what they are programmed to do. But I would claim that this is a misconception, because even if they are programmed to do whatever they do, their behavior or whatever they do can be surprising or what is called emergent. So the programmer cannot know what will be the behavior of the system afterwards, when the system kind of goes away from the hands of the programmer. There are various reasons for this, and the main reason is that more and more often programs are set to be in interaction with data or some, let's say, simulated experience of the world, whether it's texts to be read or images to be seen or speech or sound to be processed. It means that systems have somehow artificial simulated experience of the world, and the programmer originally cannot really know what this experience will be. And this experience will have an impact on what the system then will do and will be able to do. The question whether computers do only what they are programmed to do is parallel with the question whether the concepts that computers hold or process are programmed into them, or whether computers could possess skills of individual autonomous concept building, construction of new kinds of conceptual structures. The answer to this question to many might be that no, of course computers can't be autonomous in building concepts. But on the other hand, it seems that this question, or the answer to this question, depends really on what the kind of approach is taken. So there are, within machine learning, there are different paradigms, and the main paradigms are called supervised learning and unsupervised learning. In supervised learning, the approach is typically such that one gives some kind of data to the system, and the data is already pre-classified or categorized, so that the idea that what the right answer or right category to each item is, so is determined by human beings. and thus the system is really not autonomous in a conceptual manner. But on the other hand, if one takes the unsupervised learning approach, it's actually possible to think of computers as artificial creatures that really construct also the conceptual system in themselves based on the data that they kind of see or experience. And these conceptual systems or conceptual structures based on the data could be different from any conceptual system created by human means, by human thinking. And this raises the question, what is the reason or what is the why this could be useful? But in the case of very complex systems, actually we could think of a situation when we can use computers to help us to deal with very complex phenomena. This kind of approach could be useful, for example, in the case of digital humanities. Humanities and social sciences belong to the most complex areas of science in the modern world, where the complexity of the phenomena related to these disciplines are by far, to my view, more complex than anything that is being studied, for example, within the natural science, more in the area of natural sciences. And that means that the computational means to deal with these kind of issues actually need to be more complex than the ones that are being used in relation to natural sciences.